So hi, nice to meet you. My name's Jonathan Victor, and I work at Protocol Labs on IPFS and Filecoin. So today I wanted to talk a little bit about two things that I think folks in this room probably are familiar with, or two specific stories. One about rugs and one about bubbles. So on the left we have a project that was launched by a Twitter user, neither confirmed, earlier this year. So specifically what he did was he created an NFT drop, all these generative pictures of crypto personalities, and subsequently rugged his own project, swapping out the images for actual pictures of rugs. On the right, we have Fuck Bubbles, which was a project that launched in about June of last year. You can mint a little speech bubble that said fuck XYZ, and then you could have the creator would swap out the actual speech bubble to say something else. It would be a marketing stunt, things like that. And I think the reason these two stories are interesting is for folks who are new to the NFT space, sometimes it subverts the expectations that they have. When people talk about NFTs, they say this content's immutable, it's permanent, it's persistent, all these things associated with blockchains. And so the idea that it's possible that you could have an NFT that breaks or mutates can sometimes go against what they might be expecting. And so to understand how this is actually happening, we have to take a look under the hood, which can then inform how we fix that. So this is the only slide with code, I swear. But I think it's important for people to take a look at what exactly an NFT actually is. So every blockchain has a different standard or set of standards. On the left, we have the ERC 721 standard. And what you can see is any token that meets this contract specification definition is technically an NFT. It'll have a name, it'll have a symbol, and it'll have a link to some JSON object that's hosted somewhere else out in the world. And it's important because that's the only thing that's actually written onto the blockchain. That's the thing that's immutable. On the right, you actually see what that token URI is pointing to, or an example of one. That's what the JSON metadata blob actually looks like. It'll have a couple properties. It'll have a description, it'll have a name, and most importantly, it'll have the actual image URL, wherever that content's actually being hosted. You can see the highlight over there that sort of shows what that would look like. And so why is this bad, and how is it possible that we had these two projects that were able to mutate NFTs? Well, when you have a centralized URL, so something that's like HTTP, you're not pointing at a specific picture, you're pointing at someone's server and some file that's hosted on that server. And that might click something in your brain. You have this immutable distributed ledger, but somehow you're pointing to someone else's asset that you're hoping they're gonna keep around and not destroy or not mutate or not do anything to. And so reasonably, we don't actually want our NFTs to be pointing at someone's server. We want the NFT to point to some actual picture. We don't want it to point to a location, we want to point it at a thing. Thankfully, we have a way of doing this. This is what IPFS is for. So IPFS is a protocol, it's not a blockchain. It's a protocol that allows you to store and retrieve content based on a fingerprint of the content itself. The important twist in the way that IPFS is different from the centralized way that you typically access data is you're not asking for a specific location and saying, please give me whatever is there. Instead, you're saying, I would like this specific thing, can someone give it back to me? So in our little example over here, we have NyanCat down at the bottom, and you can create a fingerprint of that NyanCat, and it says Baffy CMJ. Your computer can ask the IPFS network and say, does anyone know who has a copy of Baffy CMJ? And any computer that's running an IPFS node can check and see if they have it, and if they do, they can serve it back to you. That means the content can live anywhere. It doesn't have to live with any specific user. It could live in AWS, it could live on a local computer, it could live on a decentralized storage network. Anyone who's hosting it and serving it back to the IPFS network can hand you back your content. Of course, this doesn't solve everything. That solved only the immutable reference. What happens if no one's storing the content? Your link still won't resolve. So we need some way not only of saying, how do I immutably reference content? I need some way of guaranteeing that that content's going to be around and served by someone else. Thankfully, we have another solution to that problem. This is where Filecoin comes in. Filecoin is a crypto protocol. This is a blockchain where anyone can provide storage capacity to the network, and when they do, they're required to do a couple of things. The first thing they're required to do is put up economic collateral. When they take your data, they are required under penalty of losing that economic collateral to prove on a regular cadence that they're still holding your data. This is exactly like an on-chain cryptographic SLA, the same way that Amazon will pay you if they have their server outage for like 95% or whatever, Filecoin guarantees that your content will stay around under penalty of that person losing money. The second important thing here is because this is a decentralized network, all of these proofs are verifiable. You can look at the chain to see that your content hasn't been lost. Relatedly, Filecoin is a very large storage network. I don't know if people are familiar with the term ebibyte, but if you think of the scales of data, it goes gigabyte, terabyte, petabyte, exabytes. As of 2 weeks ago, when I made this slide, it was at 12 ebibytes of capacity. We're actually at 13 now. For some context, that's like 1.8 million terabytes. It's quite large. It's large. And I'll get to a point of why I think that's super important in a second. But because Filecoin is this open storage market and you have so much capacity, it makes it incredibly cheap to store on the network. Honestly, when I was writing this slide, the best way to represent the actual cost of storing data on the Filecoin network was scientific notation, which I think when we start thinking about how do we do this at scale is incredibly important. So putting it all together, why do we need these different things? Well, I think everyone in this room probably believes that NFTs are the nascency of where they will be. And when we start thinking about what does it look like to have billions of NFTs, every ticket, every vaccine card, every game asset, HD videos, proof of attendance protocols, there's literally billions of things that we need to digitally represent. We needed to do it in a way where no content's lost, the content can be verified, and we can do it at a price point which makes it actually reasonable to do, which together with IPFS and Filecoin you can. So the last point I'll make is peer-to-peer protocols can be quite hard. We've built a number of tools that make it incredibly easy for people to get started. You can mix and match with whatever infrastructure you want to run yourself versus things that are hosted. NFT.storage, that's actually something OpenSea uses today. Estuary, that's something that Zora uses today. These are all tools that are battle tested, and I'd encourage people to take a look. And I'll be around this conference if other folks have questions. Thank you. They're doing mostly the same thing. They have slightly different APIs. So the benefit of NFT.storage, the question was difference between Web3.storage and NFT.storage. They both will do the same thing of pinning your stuff in IPFS and pushing it to Filecoin. The slight difference is NFT.storage has a bunch of handy APIs that make it really nice. So if you're trying to mint an NFT like metadata thing, it will actually just, you hand it some parameters, it will hand you back the right JSON file that you need to like the CID that you need for your thing. So it's more geared towards NFTs, but the actual backend is the same.
Can you explain the applied difference of that? Like, what does that mean in application when you're actually using the asset?
What do you mean by that?
If I'm looking at the application, the main difference there is just the way the file is stored or the way the file is presented?
No, the main difference is just the API that a developer would use to integrate. So if you're building an NFT marketplace, it's way easier to use NFT.storage. If you're building a normal web app, you might find Web3.storage easier.